Okay, today we are going over 2.3i, the class activity, which is going to teach us how to derive the equation y equals mx. What that tells us is, where does y equals mx come from? So, if you'll open up your class activity, this is page 115, 116, somewhere in there. If we read here, the first part says, write down what you know about linear relationships below. So we have three things. So first, you need to write down, a linear relationship is defined by its constant rate of change and its initial value. So linear relationship, that's the constant rate of change, like our slope, and the initial value, like where we start. Number two, the constant rate of change in the graph of a linear relationship is called slope, and the initial value is the y-intercept. So that's basically what I said on the first one. So go ahead and write, so rate of change is slope, initial value is y-intercept, and finally we have the third one. The equation y equals mx plus b relates the x to y, where m is the slope and b is the y-intercept. Okay, now we're going to talk about the differences between those linear relationships and those things we know there to proportional relationships, which we're going to put in the bottom. Proportional relationships are a little bit different. First off, it says a proportional relationship is a special linear relationship. So they are linear, but they're a special kind. Number two, a proportional relationship is defined by a proportional constant, or a unit rate. Remember, that's when we do the y divided by x, and it's the same all the way down the table. That's that proportional constant. Or you can do a unit rate like $6.25 for 5 pounds becomes $1.25 per pound. Number three, the proportional constant is the same as a unit rate in a proportional relationship. So those two are the same things when we have a proportional relationship. And you can interpret that as the rate of change. So it's like the m in our y equals mx plus b. It's that m part in a proportional relationship. It says when a proportional relationship is graphed, it's a straight line going through the origin. So they go through 0, 0. And finally, we can create an equation that relates the x to the y value. And so that's what we're doing today. We're creating the y equals mx equation. Notice there's no b, there's no y-intercept, because that y-intercept is really 0. And so it goes through the origin, so you don't need to put it, just y equals mx. If we look down here at number 1 now, it's going to give us some instructions here. It tells us to graph a line on the coordinate plane to the right that goes through the origin and has a slope of 2 over 3. So if you guys come down and you do that, you're going to go up 2 and over 3, and you're going to draw in this line here. And then you created a slope triangle, we call it, where you rise 2 and you run 3. Number 2. Does this line describe a proportional relationship? The answer is yes, because it's linear and it goes through the origin. Number 3, now it says choose any point x comma y. So if you look up here, they put x comma y up here. And they said draw a slope triangle that describes the rise and the run. So we're going to rise y and we're going to run x. And that's going to create a new slope triangle here. So you should have 2. You should have the 2, 3, and the yx. Okay, and so they drew them down here so you could see what those slope triangles look like. Now if you look at these two are a dilation of each other, which means they are similar triangles. And we talked about how similar triangles are proportional. And being proportional, that means their side lengths are proportional, so we can create a proportion, like down here, number 4. So number 4 says 2 over 3 is equal to y over x. The rise over the run equals the rise over the run. And so when they're proportional, That's something like saying 6 over 4 is equal to 3 over 2. It's just you're simplifying our equal. That's what a proportion does. Okay, number 5. Solve the equation that you wrote above for y equals 2/3 x. So what we did is we multiplied the right side by x. That canceled with this x, but we also have to multiply x on the other side. And so we ended up with y equals 2/3 times x, which is what we have down here. Notice that this is in the form y equals mx because the y-intercept is 0. And so this is a proportional relationship. So now we look at a general case. Instead of using a rise of 2 and a run of 3, we're going to do the same thing we did up above, but now we're going to do it with a general case. So it says graph a line on the coordinate plane to the right that goes through the origin and has a slope of m, meaning we're going to rise m and we're going to run 1. So whatever m is, because m is our slope or our rate of change. In this case, it's our proportional constant. So we do that, and then we do the same thing with the y and the x. So we create our two slope triangles here. One is m and 1. The other is y and x. So they drew these down here. Number 7 says, is this a proportional relationship? Yes, again, it's straight and it goes through the origin. So number 8 says, so number 8 was the y over x, the y and the x slope triangle. So we did that one. And now we can go to 9. So 9 is write those proportions. We have the rise over the run equals the rise over the run. M over 1 equals y over x. And now we times by x again. And so it creates y equals mx. And this is the exact equation that we were looking for. Okay, if we scroll down or go to the next page, number 11, it says show the equation for a line that goes through the origin and has a slope of 2 over 5 is y equals 2 over 5x using dilations and proportionality. So we create our slope triangles here, one of 2 over 5 and one of y and x. And so that's a dilation because it looks the same, it's just bigger. Remember, a dilation creates similar triangles, and similar triangles are proportional. So we can use those proportions, 2 over 5, the rise over the run, to equal the other rise over run, y over x. And then when we multiply by x on both sides, then we get y equals 2 over 5 times x. So it says the rise of the right triangle formed when the point 5, 2 and the origin is 2 and so the rise is 2 and the run is 5. You choose any other point there. The rise is x and the run is y. Using that proportion, we create y equals 2 over 5x. Perfect. And that's it. So now you just need to turn your page to the next one and do your homework assignment. And it's just this one page, so when you're finished with this, go ahead and do your homework. Anything that you're missing, you can catch up on.